How we can define explicit and implicit constraints? So again, these are the same questions that you'll be asked in Vivas as well. That you need to know the difference. Explicit constraints relate xi की value कहाँ से आएगी, and implicit constraint the relationship between those xi values if we are dealing with n queens or whether we are dealing with 15% problem. So again, these are three type of problems. कैसी problem पूछी गई है, that will make us decide how the solution should be or what is the expected solution. Then these are some terminologies that we studied in both the types. Then, as I mentioned, how do we improve the search solution in case of DFSs? We can backtrack, and in that way we can avoid generating few of the nodes. So this was a comparison with 3D. And then these are the three problems that we have in the syllabus. We saw them one by one. So n queens problem, now you people are able to define, and you can solve it manually. You can solve it through algorithm. And you can represent this in the form of a tree as well. So we were trying to reduce down this 8 to the power 8, that is huge search space tree, into generation of 8 factorial nodes. So these are the explicit and implicit constraints for 8 queens. Or we reduce down this to 4 queens as well for interpretability purpose. So this is how the nodes are explored, because we are following DFS that leads to 4 factorial leaf nodes. And this is how whenever you are answering, though on the slide it is not mentioned why the bound has happened, but you have to give a reason whether it is on the same column or in the same diagonal, the right diagonal or the left diagonal, if you want to be more precise in terms of the marks. And same column क्यों नहीं हो रहा है? Because we have kept a constraint that every level represents the queen in the next row, a new queen in a new row. So before that, we try to understand कि हम manually जब करते हैं तो how do we represent right and left diagonal. Accordingly, we have placed that thing in the code. So in the code, we are one by one placing the queens. So recursively, we are calling for placing the next queen in the main process, and then we are checking whether it is feasible for us to place the queen or not by this place method. This place method is checking for same column and same diagonal. I hope this is done by people, though the deadline is day after tomorrow. The next problem was sum of subset. हमें एक subset दिया हुआ है, and we are asked to pick up the item so that the sum of those item weights is equal to a given number. So again, there could be multiple solutions in this. So this could be an enumeration problem. This could be, this is a varying tuple. This solution could be in form of a fixed tuple, wherein every tuple is having a binary value, either 0 or 1. Again, you can see that here explicit and implicit constraints have been specified, and there are 2 bounding conditions. So whenever we are solving sum of subset using backtracking, जहाँ पर भी bound होगा, you have to mention whether it is due to condition number 1 or due to condition number 2. And when you are writing the algorithm, also you have to ensure that both the conditions are being mentioned in the algorithm.
How to specify which position there is a bound while writing?
देखो ये जब ये यहाँ पर लिखा B, तो you can write the 2 conditions as 1 and 2, and directly you can write B1 or B2. So that is saving your space as well as time. यही पूछ रहे थे?
उस पर्टिकुलर नोड के ऊपर बाउंड रहेगा, वो सारे नोड्स के लिए वो करना रहेगा, तो वो पर्टिकुलर नोड कैसे स्पेसिफाई करें?
वही तो बोलियो, यहाँ पर मैंने क्रॉस लिखा है, instead of that you write B1 or B2 in the tree itself. So we are able to understand why the bound is happening because of the first constraint or the second. So online students also must have understood. His question was कि हम कैसे specify करेंगे. So this could be one way of specifying. You can use your own techniques. So instead of cross, you can write B1 or B2 that represents the bound is happening because of first constraint or second. So again, we saw a number of problems for this. I again assume that people must have practiced any one problem and will submit this as a solution. So this is a code. Again, we have the two conditions over here, the first one and the second one. And the complexity as well. So again, for this tree, I had told, though for practice, there are 6 elements, but in exam, the size might be reduced because you can see, because though I have not explored the tree entirely, but still it is very huge. So again, the question could be in the sense, agar first solution aa jata hai, you can stop. So only one solution is required. If multiple solutions are required, you have to expand the entire tree along with the bound. तो यहाँ पे जैसे B लिखा हुआ है, you can specify whether it is B1 or B2. Now moving to the third problem. That was graph coloring. So again, there are few terminologies related to that. What is chromatic number, then what is 4-color problem, that or how many minimum number of colors are required to color a particular graph or a map. So again, when we look at the algorithm for this, we get to know the complexity. And this was one of the solutions. Again, the partial tree was mentioned over here, but because we were getting the solutions in the left subtree, and if only one solution is asked, then you can do away with this much. You need not do the entire tree. Then we had moved to with branch and bound technique. Again, this is dealing with optimization problems. The difference. And then in this, we saw different things as we need to compute a condition that lower bound and upper bound. If lower bound exceeds upper bound, definitely that is a bound. The two terms, branching and fathoming. Then the 3 ways of implementing branch and bound through BFS, through D-search, or using LC cost. So for LC cost, we had the algorithm, which is using a heap that is implemented as a priority queue that keeps track of the cost of each node. So irrespective of the node being in the same level or in the same branch, I can switch between levels or branches, whichever is having lesser cost. But that will be again at the cost of storage, because I'll have to store the cost of these each and every node jitna bhi hame requirement hai. So again, how is the cost being computed? Because again and again I'm using the term cost. So this is a intelligent ranking function. Kitna kaam abhi tak ho chuka hai and how much work we need to do. We do not know that work, so we are putting an estimate of that to reach to the goal node. So this estimate will differ from problem to problem. So 15 puzzle के लिए हमने estimate क्या ले लिया कि हमारा काम कम लग सकता है if I just count, though actually when you are solving the problem ऐसा जरूरी नहीं है कि अगर 4 misplaced tiles है तो only 4 movements will be required. You might require more movements. So this estimate is always again a bound. So in 8 puzzle problem we said the number of misplaced tiles. So whenever we are drawing this tree kind of structure, we're always checking that this gx value should be the minimum value, and at one by one at each step I am picking the minimum value. So last me this estimated gx has to be 0, and slowly it is being reduced as we traverse from the root to the core. So this is all we saw. Again, the example problem that you have to solve for practice. So today we are beginning with module 6, that is the last one. Though this module does not go with the 5 strategies जो अभी तक हम use कर रहे थे for solving the problem, this is completely different. That is, this is dealing with string matching algorithms. String matching algorithms कैसे कोई भी pattern match करना है, कोई भी search algorithm that is running online as well. Let us say for this in Google, in your DOS operating system, there is a find function. So at the back end, what search algorithm runs, or over the internet on Google when you want to search an item, what kind of algorithm runs. So those kind of basic, again, many algorithms we will study over here. That is why your last experiment, that is experiment number 8, is a case study on these all 5 types of string matching algorithms. And this is the last part, which may be excluded for study by students who are not able to comprehend it, because iski understanding thoda higher jati hai. But again, those who are able to understand, they may take this. I'll cover this in the next session. So before I go ahead, I have a couple of questions. How do we define a string? Set of characters. Anything missing in that? ये हमने LCS में भी पढ़ा था string. तो set of characters अगर बोल रहे हैं, that could be a subsequence, a sequence as well.
Sequence of characters.
Sequence of characters, contiguous sequence of characters. Now that completes the definition. The characters must be one after the other, right? Okay. Then there are a few terms related to strings as prefix and suffix. You must have studied in TCS. So prefixes. अच्छा, let us consider a string as module पकड़ लेते हैं. So what will be the prefix of this word? M or MOD?
MOD.
MODU. Okay.
MODU, MODUL.
Fine. So we know what a prefix is. What about suffix of the same word? E.
Operation sign.
Operation sign मतलब अभिषेक?
No, ma'am. Actually, that
कुछ misinterpret किया तुमने? Yes. E, LE, ULE, DULE, ODULE. Are we taking the entire string as a prefix and suffix? ठीक है. अगर single alphabet, let us say 6 is a string. So what is the prefix and what is the suffix? Both is 6. अभी तो बोला entire string को नहीं ले रहे हैं as prefix and suffix. Single character होता तो नहीं लेते हैं, और entire string रहती है तो I don't take the entire 6 अगर length है string का तब हम नहीं लेते 6 length का prefix और suffix. इसीलिए मैंने TCS का नाम लिया. Epsilon और empty string is a prefix and suffix. Single character से prefix और suffix नहीं आएगा. That will be an empty string. That is why पूरा module जब consider कर रहे हैं तो module in itself, the string itself cannot be the prefix or suffix. ठीक है? Okay. So these are the few concepts related to or the prerequisite for this module. String is a sequence of characters. Examples of strings could be any Java program, any HTML document, DNA sequence, any image. DNA mapping जब करनी है तो those are sequences of characters as G, A, C, and T. We are trying to map the characters basically. Similarly, ये जो plagiarism के code होते हैं या there are code to check whether two codes are same or not. So that particular software is basically checking code whether any program has common set of lines or not. When you are checking anything on the web, then it is comparison between HTML documents. Then there is a terminology as alphabet. So alphabet is जहाँ से characters आ रहे हैं for that particular string. So the alphabet could be an ASCII code, a Unicode, a binary alphabet, or a DNA sequence as A, C, G, and T characters. Then prefix and suffix we have discussed. Then whenever we are matching or we are studying any string matching algorithm, then we'll be given two strings of which one will be the text and one will be the pattern. Normally text is of larger size and pattern is of smaller size. We are trying to find occurrences of pattern within the string. First occurrence or all the occurrences. Again, there are some terminologies related. ये string दी हुई है. Length of string we know the substring, we know the subsequence because we have already seen this in LCS. Prefix and suffix we have seen just now, the official definition being 0 से लेकर ith character. So I could be anything lying between 0 and m minus 1, where m is the size of the pattern. मतलब m characters हैं pattern. Similarly, suffix could be end से, that is why m minus 1 तक ले रहे हैं, लेकिन I could be any value again between 0 से m minus 1. So these are the examples of possible prefixes and suffixes as you people answered. So this is your string, this is a substring, these are possible prefixes and these are possible suffixes. Though the entire string is mentioned over here, but we are not taking it. जब भी हम उसका algorithm पढ़ेंगे जहां पर prefix and suffix is being used, that is KMP algorithm. So after we have done with the initial concepts, let us now move to algorithms जो पढ़ रहे हैं उसके लिए problem क्या होगी. So the problem will be string matching problem and the algorithms will be string matching algorithms or pattern matching algorithms. So as I mentioned, you will be given a pattern, you will be given a text, you have to identify the pattern in the text, and it might be possible that you have been asked to find all the occurrences of pattern in the text. So again, these are the applications where string matching algorithms can be used, as I have mentioned earlier as well. So ये pattern, we can see it is there in the text. It might not be there in the text. So your program might return a -1 value or not found, etc., depending on your implementation. So what is the naive or the brute force or layman approach of finding a pattern in a string, in a text?
Search the whole string one by one going forward.
तो अगर मुझे ये पैटर्न फाइंड करना है ये स्ट्रिंग में, दैट वाज माय क्वेश्चन. सो व्हाट आई डू इज आई try to match it character by character from beginning of the pattern in beginning of the text. ठीक है, right? Online students, I'll compare G with A. So it is a mismatch. Now what should I do?
Next.
G with the next character. So in this case, what I did is, whenever there is a mismatch, what I am doing is, let us say text में जो pointer था that was I and pattern में जो pointer है that is J. तो अगर mismatch हुआ, am I incrementing J? So from manual logic, now I am converting it into a code. If it is a mismatch, then we are not changing the value of J, we are only changing the value of I, because now I have to compare G with the next character in the text. Agar match hua, then what I should do? Anyone online? If there is a match in the character of the pattern with the character of the text, what changes are to be made to the pointers?
We increment J
Only J?
and miss I also
I
for checking the next.
If there is a match, we are incrementing both I and J. If there is a mismatch, we are only incrementing I, because J का पहला pattern का पहला character match ही नहीं हुआ था, so I have to still check for that character. So I'll not modify that. So this was the first technique that we were discussing, the naive method or the brute force method, or we call this as a layman technique. We have other techniques, one after the other, which we have to cover is Boyer-Moore and Knuth-Morris-Pratt. Those are called as two-phase algorithms. They pre-process the pattern to make a decision कि हर बार हम एक increment आगे नहीं बढ़ेंगे. Can we skip more intelligently so that we have lesser number of comparisons? Similarly, we have Rabin-Karp and string matching with finite automata that covers concepts of TCS. So these two algorithms we see in the next lecture. Today we cover these three algorithms. And today I want participation from people, in the sense I'll tell you how it is to be done. Then I'll give you an example, and here itself you will apply the algorithm and tell me the answers. And again, I am marking out the row numbers. So the first one we are aware of, मेरे पास एक pattern है. And it text here, the first character matches. So as you people said, A is matching, G is matching, C is matching, and there is a mismatch. Now what should I do is, मेरा naive approach क्या बोलेगा कि मुझे फिर से पैटर्न का स्टार्टिंग चेक करना पड़ेगा with the next character. This is without using any logic, any intelligence mechanism. अभी इतने में अगर match नहीं हुआ, so let me check the remaining part of the text. So I'll start comparing the beginning of J with the next of I. Because a mismatch has happened, so this pattern is not there in the text. So because this pattern is not there in the text, I'll start comparing this pattern with the next position. ठीक है, so in this case you people can understand, अगर text का size है number of characters are n and pattern weight is m, so how much time will this take?
into n.
m into n, right sir, right, because मेरा एक for loop है जो I को increment कर रहा है, एक for loop है जो एक j को increment कर रहा है, so this iterates over m into n times. Now let us move to the pseudocode. So the code, what does it say is, input text t of size n and pattern p of size m, starting index of the substring of t equal to p, it will return a substring that is there in the text that is equal to pattern, जो हमें identify करना है, लेकिन क्या return करेगा? जो beginning index होगा text में जहां से pattern begin होके match हो रहा है text. Like in this example there is no match, but let us say TCACA was the pattern, so this will return I value as 7. Okay. Or if there is no such substring, the pattern does not match in the text, then -1 will be returned. So that could be implementation basis. Now my question to you people is, why am I taking this outer loop from 0 to n minus m and not from 0 to n?
Because the length of the string that we have to search is there, and if we move from n minus 10 forward,
so worst case may, let us say my sequence is these 8 A's, my pattern is these 8 A's. तो मेरा जब pattern आगे shift होते होते, if my pattern reaches at this place, then my matching is starting one by one till the end I am receiving. तो मुझे return क्या करना है, ये algorithm को return क्या करना है, ये beginning location where the match happened, right? तो इसके लिए जो outer loop है वो सिर्फ यहाँ तक ही run होगा. Inner loop, let us say it runs how many times? So inner loop, by seeing at the code, can you people answer it is executing how many times? Okay, और एक and है वहां पर. तुमने ये फर्स्ट कंडीशन से बताया होगा, j less than m. Why is this being there? Anyone online? Please explain me this while statement that is over here, what is happening here. And ये loop कितने times run करेगा, this while loop. So one of the offline student answered that is while loop executes m times. So then why are we having this condition?
सेम रहेगा t और t में, तो +1 से का +1 होगा, तो सेकंड j का सेकंड वाइज तो वैसे, और फिर अगर इक्वल नहीं होगा.
Okay, let me change the question. When can I come out of this while loop? First condition. When, if any of the particular character is not matching, I am coming out of the while loop. Second condition. if all the characters have been mapped. There are no answers from online students. मेरा क्वेश्चन क्या था, इस while loop से बाहर कब आ सकते हैं? Because there is an and condition. Either this is false or this is false. We come out of the while loop, right? When this is false means, that is why we are having an if statement here to know कि इस while loop से बाहर we have come out of this condition or out of this condition. What is this condition? J less than m नहीं है. That means j increment होते होते it has reached to m. That means we have checked the entire pattern. So if j has come by incrementing equal to m, that means the entire pattern is there in the entire text, in the text somewhere, and I should return the value of I. ठीक है. अगर हम लूप से बाहर आए because of this condition not being satisfied, that means a particular character of the pattern is not matched with a particular character of the text. That is why we are moving out. उस केस में हमें क्या modify करना है? J की I, only I. So that is why.
Ma'am, I.
Yes, that is why we are inside the for loop wherein I is being incremented every time. J has to increment, J does not has to increment. J increment कब होगा? जब J की वैल्यू लेस देन m है, तब नहीं इंक्रीमेंट होगा. जबकि ये कंडीशन फॉल्स हो जाती है तो J is again initializes. So automatically your algorithm is taking care of what we discussed manually. Let me repeat this. Why are we taking this loop from 0 to n minus m? Because in the worst case, अगर pattern match हो रहा है and it is present in the last in the text, so its matching should begin at n minus mth location and आगे की m locations one by one match कहाँ पे हो रहे हैं? You can see over here. This is I plus j matching with j. So n minus m plus 0 we are trying to match, trying to compare with p of 0. N minus m plus 1 trying to compare with 1 and n minus m plus m trying to compare with m. अगर locations 1 से m start हो रही है, अगर 0 से m minus 1 लिया तो accordingly it will change. So that is why this for loop is from 0 to n minus m. We are initializing I here, we are initializing j here. Now we are checking ये iterations. हमारे पास दो possibilities थी. Either I am getting a match, I am getting a mismatch. If I am getting a match, then I am checking whether my pattern is complete or not. If my pattern is not complete, I'll iterate over the next value of j and I automatically increase over x. So I'll compare I is fixed and accordingly t में shift होगा जैसा कि p में shift हो रहा है 1 place further if I am getting a match. If I am getting a mismatch, then I'll come out of this while loop, and this coming out of the while loop is not because my entire pattern has been searched. That is because of what? There is a mismatch. तो इस केस में हमको क्या करना है? Brute force क्या करता है? I have to again start comparison of the pattern from the first index in the pattern to I की जो भी current value है. Right? This is what we saw manually. So is this understood by all? ये करते करते if I am coming out of this while loop because my j value has reached to m. So if I am coming out of this while loop because of this condition not being satisfied, that is why I am checking the condition here. I'll return I. If I am coming out of this condition, I'll break the while loop. Again, for the next value of I initialize the pattern from the first index. And ये करके if I reach to the n minus mth location in the text and I do not find the pattern, I return a value as minus 1. So I hope this is understood by people. If it is not clear, so when we practice the question, it might be clear, or when you do self-revision, it should be clear. So this is what we saw, that brute force pattern matching algorithm compares pattern P with text T. For each possible shift of P relative to T, we are doing 1-1 shift until either a match is found or all placements have been tried. So if a match is found, I return I. If there is no possible placement, I return -1. That is why there are only 2 return statements. So this we have already discussed, that there are 2 loops. So the complexity when we bound it is n into m. And this is the worst case. जैसे मैंने पिछले example में भी बोला, अगर pattern those 8 A's या 6 A's का comprise हो रहा है, that will be the worst case. And this worst case might occur in any image wherein there is a match in the end, or there might be a mismatch in the end. Khali last particular pixel is differing, or in any DNA sequence. It is not likely in English text. Now we'll see an example. I have missed to mark this as red. There are some red stuff in the slide. For example, this. Why is brute force used for small p? So all these answers are required when you are being assessed in the practicals. Sorry. Switch कैसे हुआ? So why is brute force being used for small sized pattern? So this is an example of brute force algorithm. When this is a small text, this is a small pattern. So there is a mismatch. So what we do is we move it forward, then again we'll move it forward, and we reach here, and then we start comparing one by one, and we return this particular location as output. Now again, the first assignment for brute force is this is a text and this is a pattern. Manually you will execute this and then through the algorithm, or you can do it together. Manually जब भी लिखा है वहीं पर algorithm का step you can write what is the value of I and what is the value of j and which condition is being used. Brute force is fast when the alphabet of the text is large and it is slower when the alphabet is small. So again, this is a question that may be asked while evaluation. When I am using English text, that is from capital A to Z, English alphabet from capital A to Z or small a to Z or from 1 to 9, then why is brute force taking more time, and why it is taking less time, and why it is taking more time when it is a binary string. This we have already discussed. This is an example of worst case, and this is in any average case जहाँ पर कुछ characters match होंगे और कुछ characters mismatch हो जाएंगे. Fine. So you people have understood that you have to execute Raman likes mango with the pattern mango in this manner, as well as here only you have to mention the algorithm ka. You can number these lines, write the algorithm and just mention the line number, one way of doing, or you can write I or j की current value क्या है और इस while loop में condition में value is being satisfied or not. For example, 0 less than m and t of 0 plus 0 is equal to p of 0, like that. I'll show you that for the other algorithm that we see today that I've added in the slide. So now let us move to the next algorithm or next set of algorithms. As I mentioned, these are called as two-phase algorithms. Two-phase में first phase क्या करते हैं? We are trying to find out. We are trying to pre-process the pattern. That is the first phase, and in the second phase, we are trying to use this pre-processed pattern key value to iterate faster and use lesser number of comparisons. So again, these are the two links available on Java Point. You can refer those to understand these algorithms better. Now let us begin one by one with these. So Moore, again, it is by the name of the developers who have designed this algorithm. And there are a few heuristics that we'll be studying here. First heuristic that is mentioned on the slide is looking glass heuristic. So first thing that you have to remember is यहाँ पर हम pattern का जो iteration है we begin backwards. So we are initializing j with m minus 1 and then slowly decrementing it, as you can see over here. सबसे पहले इसको compare करो. Second thing is character jump heuristic that says whenever a mismatch occurs at ith index of text with a character C, देयर आर टू पॉसिबिलिटीज. मिसमैच हुआ तो क्या वो ith कैरेक्टर कहीं और है? If P contains C, I align that character with a character in pattern. For example, there is a mismatch happening here. ith index पे कौन सा character है? T. Is this character T present in the pattern? It is. So we simply align this with this, as is happening here. ठीक है. अगर मिसमैच कैरेक्टर नहीं प्रेजेंट है पैटर्न में, फॉर एग्जांपल लेट अस से हियर E is not there in the pattern, so I'll shift P to align P0 with Ti plus 1, or verbally we say this as we are completely moving ahead of the mismatch character. So mismatch character कौन सा था? ये, इसको bypass करके now my starting position of the pattern will match the next ith value. So as you can see, this E was not present in the pattern, so I'm completely shifting this ahead. What will happen now in third case? Am I following first condition or second condition? Is A present in the pattern, the mismatch character? So what should I do? Completely shift. As you can see over here, हमने क्या किया? We have aligned P of 0 with Ti plus 1. I कौन सा? जहां पर mismatch हुआ था. Again N नहीं है, so we are completely shifting this. G नहीं है, completely shifting this. And the mismatch character H is there in the pattern. So what should I do? Align the mismatch character with the character in the pattern. So H is aligned with H, irrespective of बाकी सब हमने नहीं देखा, हमने सिर्फ H को H से align किया. Now what is the next step is I compare character by character from the last of the pattern to the first. So 7, 8, 9, 10, 11. These are the 11 steps which Moore has got. Whereas brute force को कितने steps लगते हैं? M into N. Right? So in brute force you would have worked in this manner. Rhythm आता, फिर again mismatch की वजह से again we'll compare rhythm and so on till we reach here, that is n minus mth location, and then those m comparisons will happen. So that is why n minus m plus 1 into m minus 1. Okay. So after we have seen this, let us check out the properties and then the algorithm. So first thing that you have to remember is Moore works backwards. It decides how many positions ahead to start the next search, and that decision is happening on the basis of the value of the character causing mismatch. हर बार हम यही देख रहे थे कि जहां पे mismatch हो रहा है वो text में कौन सा character है. With each unsuccessful attempt to find the match, information gained is used to rule out as many positions of text as possible where strings can't match. So we are trying to shift this pattern intelligently, not once every time, but more intelligent shifts. So if the pattern is there, if the text is there, the mismatch character is there in the pattern, we are aligning those two. If it is not there, then we are completely shifting past that mismatch character. This is the most efficient way and fastest for moderately sized alphabet and long pattern. So again, this is marked in red. So again, you have to look out the reason, the justification or the analysis for this statement. Why is Moore most efficient or fastest for a moderately sized alphabet size? And if the pattern is long. Pattern is long के लिए अभी भी कोई बता सकता है? Right now, if the pattern is long, why is Moore better than your brute force?
Because it's taken from backwards, so the number of times the iteration has to be performed is reduced.
Pattern अगर long है तो जब भी mismatch हो रहा है, जब वो mismatch character नहीं present है pattern में, हम पूरा का पूरा उठा के shift कर रहे हैं. So there are more longer shifts that are happening. So this takes lesser time, right? So such kind of justification I want wherever it is required. कौन से दो ह्यूरिस्टिक थे सबसे पहली स्लाइड में बॉयर मोर की? What were the names?
Looking glass and character
Glass
jump.
and character jump. Okay, Rudrash. So those were looking glass and character jump. Looking glass was moving backward और character jump is making us understand कि mismatch character है या नहीं है, accordingly कैसे jump करना. There are three cases present on the slides for Boyer-Moore. The first case, this is something same as what we have discussed, but यहाँ पर नाम दिया है. Bad character heuristic का मतलब there is a mismatch character, but that mismatch character in the case one is available in the pattern and available at position जो अभी हमें match करनी, that is in the left it is there. So if P contains X somewhere, then try to shift P right to align the last occurrence of X and P with Ti. So this is what we did, and this is known as case one of bad character heuristic. Right? Let us move to case 3 directly. Case 3 क्या बोलता है कि this mismatch character is not there in the pattern, so we are moving this entire pattern ahead of the mismatch character at Ti plus 1th location. We are trying to match the P of C. So this is again bad character heuristic. There were two cases of bad character, case 1 and case 3. Case 2 says the mismatch character is present in the pattern, but it is present in its position which we have already checked. So mismatch location say right में है which we have already matched, right? If I try to match these two together, this will cause a negative shift. This will cause reverb. So this is another case, that is case number 2. Now let us look how we try to solve or implement Boyer-Moore algorithmically. So in Boyer-Moore there is a pre-processing phase 1. Remember, phase 1 क्या करता है? Pre-process करता है pattern. So this function is called as last occurrence function, जो map करेगा characters और alphabet characters in the alphabet to integers. So how are we mapping? Let us say this is my pattern. What all characters are there in this pattern? A, B, C and any other character. ठीक है, इसके लिए हमने एक टेबल बनाया, that is A, B, C and any other character. And how am I mapping this to integers is the largest index I such that Pi is equal to C. Last से वो character किस index पे available. So let us look for A. If I count these as 0, 1, 2, 3, 4, 5. So A का largest index क्या होगा? 4. So that is why this LC value becomes 4. Similarly for B, this is 0, 1, 2, 3, 4, 5. This is 5. For C, it is 0, 1, 2, 3. We write it 3. And for any other character, जो pattern में नहीं है लेकिन text में हो सकता है. So for that, my last occurrence value will be -1 because my index was beginning with 0. So that is why I initialize this as -1. Okay, this much is clear?
Yes, ma'am.
Okay, thank you. So to calculate this last occurrence function, हमें time big O of m plus s क्यों लग रहा है? M is size of the pattern and s is size of the alphabet. My question is, why is the time taken big O of m plus small s? Where small m is size of the pattern and small s is size of the alphabet. जैसा इस pattern में my alphabet could have been small a to small z. Capital S is your alphabet. वही तो बोला मैंने. Alphabet का set मतलब small a से small z के सारे items. तो इस टेबल को हम कैसे प्रोसेस करें या किसके ऊपर प्रोसेस कर रहे हैं? द alphabets present in the pattern, इसके लिए M हो गया, and there are alphabets apart from the pattern which are there in the alphabet का set. वो सारे alphabets को pre process करना पड़ेगा. I will not write this -1 only for D, for every other character that is not there in the pattern but in capital S. और summation भी represent करते हैं alphabet को, capital summation. Is this clear? So that was manually we try to understand. This is the last occurrence function wherein P is the pattern, M is the size of the pattern, and summation is the alphabet set. For each character in the summation, what I am doing is we are initializing the last occurrence function array as 0 initially. Then whenever we are encountering an item from 1 to M, लेफ्ट से राइट क्यों जा रहे हैं, राइट से लेफ्ट क्यों नहीं जा रहे? तो चेक द लास्ट पोजीशन. ओवरराइट करती रहेगी वैल्यू. लेट अस से फॉर दिस एग्जांपल यहां पर पहले वैल्यू 0 हो गई, फिर 2 हुई, एंड देन इट इज ओवररिटन बाय 4. So we go on overwriting in the same array at that particular alphabet location, and then we finally return this entire array that is of size, or we can say that is of size S, right? S या summation में जितने भी characters है उसमें कुछ characters pattern में है, वो तो हमें चाहिए ही चाहिए. Apart from that, other characters also we are mentioning as -1. So this was the first part of the procedure, that is pre-processing the pattern. Now this is the algorithm, and हम assume कर रहे हैं कि हमारे पास वो pre-processed array है that is being returned as capital L. Now please try and focus. अभी तक हम सिर्फ pattern को pre-process कर रहे थे. Now I have to match pattern to text. So what I am doing is मेरे पास दो indices हैं. Why are both of these initialized as m-1? Because we are beginning from back. तो back से begin कर रहे हैं तो n-1 initialize नहीं होगा. When we were comparing here, ये भी m-1th location है और ये भी m-1th location है, right? So that is why I and j are initialized as m-1. Now we have to repeat this until I is greater than n-1. Why? ये पूरा चेकिंग जो है ये कब तक कितनी बार करनी है? Till I reach the end of the text.
When we reach the end of the loop, end of the array.
End of
Array.
which array Satyam?
With string.
End of text. Because we have to use the same terminology जो understandable हो. अभी string बोलोगे तो string is pattern also, string is text also.
Yeah, so
End of text.
text.
और text की length क्या है? n-1. 0 से n-1 is the index, length is n. So until increment करते करते, if I exceeds n-1, then definitely this pattern is not there in the text. Okay. Now let us understand the remaining. If I compare दोनों के last items और compare करते करते by decrementing the values, I reach to the beginning of the pattern. What does this signify? It is a match. जैसा ये particular example था, Raman likes mango and mango. तो इस केस में अगर हमने Moore apply किया, so in this case O matches with O, decrement I and J both, this with this with this, decrement I and J both, and decrement करते करते J की value 0 होगी, right? So if there is a match, what do I need to return?
Index at which match.
Index in the text where the match is happening, right? Because वो index starting से मुझे वो place बताएगा जहाँ पर pattern है text में. So this much is understood. If we have not reached to the beginning of the pattern, then what is to be done? अभी मैंने बोला था मैंगो के एग्जाम्पल में,
check the if the when the mismatch activity is present in the
नहीं नहीं, what I am asking is अगर मैच हुआ और j की वैल्यू 0 नहीं है, then what is to be done? I have not reached the beginning of the pattern. I have to decrement both I and j because मुझे अब next comparison करना है पैटर्न के प्रीवियस कैरेक्टर का टेक्स्ट के प्रीवियस कैरेक्टर से. So this goes on and on till I reach j is equal to 0. लेकिन ये अगर continuous matches होते जा रहे हैं, then that is the case. If there is a mismatch, that means this if is not satisfied, I move here, right? So that is where my L matrix जो pre-process हुई है, that will come into the picture. I have to decide how many character jumps I have to make. So for this, let me explain this part and this part. Can you people relate to ये एक mismatch character है which is not there in the pattern जो मुझे आगे process करना है. This is which case? Case 2 है, मैं rewrite करती हूँ उसको. This is case 2 जो मैंने सबसे बाद में discuss किया था. And यहाँ पर this is a mismatch character which is present in the text. This is which case? Of those 3 cases which we have discussed? Third था, ये था. This was case 1. ठीक है. तो ये कैरेक्टर जो यहाँ पर है, तो हम क्या करते हैं, इन दोनों को अलाइन करते हैं. बट ये तो हम मैनुअली करते हैं बिकॉज मुझे टेक्स्ट और पैटर्न दिख रहा है, उसके कैरेक्टर्स दिख रहे हैं, एल्गोरिथम को नहीं दिख रहा, राइट? सो हाउ डज द एल्गोरिथम इंश्योर दिस थिंग? सो what is the algorithm doing this? It is computing L of ti, that is the mismatch character. उसका क्या वैल्यू है फेलियर फंक्शन टेबल से? This value is stored in small l. Small l you can see here is this index. So this is trying to identify the mismatch character की location in the pattern. This and this. यहाँ पर L आ रही है, again it is matching with the character, and यहाँ पर जो L है, again this is matching with the character which is mismatched. This L will increment the value of I as either I plus m minus j or I plus m minus 1 plus l. So I plus m minus j is this location जिसमें कि मिसमैच यहाँ पर हुआ, और हम क्या कोशिश कर रहे हैं? We are trying to move past what we are trying to do in case number 2. Case number 2 we have not discussed. Okay, right. इसका केस नंबर 2 क्या बोल रहा था कि whenever I have a mismatch character that is already present, what should I do? नहीं, यहाँ पर क्या हो रहा है? What is happening from here to here? Any one of you can answer.
Miss, we increment both the values I and j.
We are incrementing both I.
And j. Oh, sorry.
Are we incrementing both I and j?
We are incrementing I.
We are incrementing both, Parth? J तो वही है, I को increment किया है. If people see
No
it
ma'am,
carefully.
no ma'am, actually we are incrementing only I.
हाँ वही बोल रही, J तो वही है. We are only incrementing I. But हम तो इसमें backwards move कर रहे हैं. So that means our I is this way and our J is this way. Now answer. So what are we trying to do? तो J minus 1 किया है I वही, because हम move right to left कर रहे हैं. So we are aligning this with this. Now let us look here. This is case number 1 and case number 2. So in this case, we have moved ahead M minus J, and in this case, we have moved ahead M minus 1 plus L, M minus this L location as well as this 1, so that this is aligned over here. So accordingly, as the case is, whether the mismatch character is not present in the text which is yet to be looked, or it is present in the text which is yet to be looked, depending on that, we are getting either either J as minimum or either 1 plus L as minimum. ये 1 plus L की distance या तो छोटी होगी या J की distance छोटी होगी. So accordingly, I get a value of I. J की value क्यों नहीं change कर रहे? या J की value क्या change कर रहे whenever there is a mismatch? Whenever there is a mismatch, I have to move from the last. Again, I have to start the comparison. Let me take you people back to the example again. जब भी mismatch हुआ, except the case where alignment is happening, we are again beginning comparison from end of the pattern. So that is why you can see over here is J की value is initialized as M minus 1. We have discussed this thing, कितनी बार repeat करना है, and if we have not found the pattern in the text, then we return minus 1. So now we'll be executing this algorithm onto an example. You people can have a look at the pseudocode. You can take snapshot of the pseudocode because the same is to be applied on the example. अभी हम manually नहीं solve करेंगे. We will try to shift back to the pseudocode. तो सबसे पहले यहाँ पर what is happening is there is a mismatch. So A and B are not matching. So we move here. Let us first look about this. AB का failure function table you people can write. Please compute the failure function table. Though this was the same thing that we were discussing. लेकिन I assume कि तुम लोगों ने लिखा नहीं होगा. So you will compute. Yes, what is the value? 4, 5, 3 and minus 1, right? Because we will refer this again and again, so that is why I am writing it here. 4, 5, 3 and minus 1 for any other character. This is A, this is B, and this is C. Okay, so over here what is happening is Ti is not equal to Pj. I am coming here. Small l is capital L of T of I. T of I is which character? A. A की वैल्यू क्या आ रही है यहाँ से? So capital L of small a is 4. L value is 4. Now put in the values over here. I is I plus m minus min of j comma I plus L. जहां पर L की वैल्यू 4 है, J की वैल्यू 0 है. m की value is 6 and I value is 0. So what is the new value of I? I repeat, I is 0, m is 6, j is 0, l is 4. 0 plus 6 is 6. So my next value of I is 6. My next value of I is 6, right? 0, 1, 2, 3, 4, 5, 6. Right? People? My original value of I was, sorry, 5. 5 plus 6 minus min of 5, 5. हमारा I और J इनिशियलाइज हुआ है as m minus 1. Remember? So this is new value of I is 5 plus 6 minus min of 5, 5. Is this much clear? Your J is 5. Why? Because of this initialization. L is 4. Why? Because the mismatch character ka failure function se value is 4. 4 plus 1 is 5. Min of these two values is 5. And 5 minus 5 is, sorry, 6 minus 5 is 1. I is 5. So new value of I is 6. तो इसके लिए I अभी कहाँ आ गया? यहाँ पर. And this location is what? 6. Earlier location was 5. J का location was 5. ठीक है, अब क्या करना चाहिए? यहाँ पर एक मैच है, यहाँ पर एक मैच है. तो जब भी मैच होता है एल्गोरिथम में, तो what we say is, if there is a match, we have not reached to the beginning of the pattern, so we decrement I, we decrement J. वही किया यहाँ पर. हमने I को एक decrement किया, J को एक decrement किया, I को एक decrement किया, J को एक decrement किया. This is a mismatch. Fine. Mismatch कहाँ पे हो रहा है? Again A पर हो रहा है. तो value from the failure function table is 4. ठीक है. And the current value of I is 0, 1, 2, 3, 4. The current value of J is 4. J की value is 4. यहाँ पे mismatch हो रहा है. So the new value of I will be, जब भी mismatch होता है, come to this else to make us decide कि I को आगे कितना बढ़ाना है. So this is 4 plus 6 minus min of 4, 5. So new value of I becomes मेरा तो आया 4 plus 6 minus min of 4, 5. Min of 4 and 5 is 4. 6 minus 4 is 2. 4 plus 2 is 6. Any one of you can correct what error we have done? Again, I take you here. So the new value of I is 4 plus 6 minus min of J is 4 and 5. So the new value of I is coming as 6 and J is coming as 6. You people can also check this out. I'll also check, though this is a solved example. आगे बढ़ते हैं. So my current value is of I is 7 and J की current value is अच्छा नहीं गलत कहाँ पे हुआ? I got that. I is being initialized as m minus 1. So I की value यहाँ पर जो ले रहे हैं that is not 6, that is 5. ठीक है? यहाँ पर जो ले रहे हैं this is 5, then 4 and then this is 3. Right? And we were taking it as 4. So always I is being initialized as m minus 1. यहाँ पर जो I की वैल्यू चेंज होके आई थी हमारे पास क्या आई थी? Let us redo this. Initially my I is 5, J is 5 when we are here and there is a mismatch. When there is a mismatch, I come here, I compute the value of L as 4 and then I refine the new value of I as 6. I is 5 plus 6 minus min of 5 and 5. That will give me a value as 6. मेरी I की नई value हो गई 6 and J की value is again 5. So I is 6 and J is 5 and I is 0, 1, 2, 3, 4, 5, 6 and J is 3, 4, 5. So I compare this. So my now I value becomes 2 कम हुआ तो 4 हो गई and J की value 3. Right? So this is what we were taking wrong. J की value 3 है ना कि 4. Because my J value started with 5. Now we are comparing this here. So again L value is 4. I recompute the value of new I. So my new I is old I, that is 4 plus M, that is 6 minus min of J, that is 3 and 1 plus L, that is 5. Min of 3 and 5 is 3 and 4 plus 3 becomes 7. Shall I repeat or write it in the text box? यहाँ पे लिखती हूँ मैं. My mistake. I thought I have put this on the slide. Maybe it was somewhere else. सबसे पहले I की वैल्यू थी 5. J की वैल्यू थी 5. यहीं पे mismatch हुआ. So I am checking for small l value as 4. And then I am computing I is equal to I plus my old value of I is 5 plus M is 6 minus min of क्या दो values का min लेते हैं 1 plus L and
J.
J. So J is 5 and I'll write this in the same manner 1 plus L. इन दोनों का जब मिल लिया, so this is 5 only. So according to this, I की नई वैल्यू क्या आ गई? Sorry, ये आए हैं. I comes out to be as 6. Then what had happened was I is 6, J is what? 5. सामने दिख रहा है J की वैल्यू चेंज नहीं हुई. So we are now beginning with I as 6 and J as 5. Then what had happened? दो इटरेशंस में मैच हुआ था, इसलिए दो बार डिक्रीमेंट होके I की वैल्यू हो गई 4, J की वैल्यू हो गई 3. There is a mismatch. Mismatch is at character A. So again L की value is 4. I have to compute the new value of I. So this will be I is equal to 4 plus m minus again min of what and what? J and I plus 1, 3 and इसको again I write this as 1 plus 4 so that when you people refer later you are able to understand. ठीक है, तो मेरी नई I की वैल्यू क्या होगी? 7. As you can see there, now I value is 7 for next comparison. That is here 0, 1, 2, 3, 4, 5, 6, 7 and this is being aligned to what? J की value m minus 1. J की value as 5, sorry not m minus 1, J की value जो currently है हमारे पास और I की value जो currently है. So this one line you are writing here, you will write this entire thing one after the other. ये इसका justification हो गया, ये second line इसका justification हो गया. Any one of you wants to give it a try for the next one? फिर से mismatch हो रहा है. तो I की वैल्यू मेरे पास है 7 करेंटली जब मिसमैच हो रहा है. Who will help me out move further? J की वैल्यू जिस पे मिसमैच हुआ that again you need not look from the example, वो ऑटोमेटिकली कोड में सेट है 5. L की वैल्यू mismatch is at which character? नहीं ये फिर से ये वाला कर रहे हैं ना. Again A पर है, L की वैल्यू is 4 because again the mismatch character is A. यहाँ पर एक mismatch हुआ था, फिर यहाँ पर एक mismatch हुआ and तीसरी बार again the character is A. So my L value is 4. So what should be my I value? 7 plus 6 minus min of J that is 5 and 1 plus 4 sorry 8. तो अभी देखो 8 पर जा रहा है मैन्युअली, ये था 7 ये आ गया 8. ठीक है, एक और कर लेते हैं बिकॉज दिस मिसमैच कैरेक्टर इज नॉट देयर, D is not there right. तो अभी मेरा I की वैल्यू इज 8, J चेंज नहीं होगा so J is 5, L is
-1.
I is 8 plus 6 minus min of J that is 5 and 0. और मैनुअली भी हम यही बोल रहे थे कि जब भी मिसमैच कैरेक्टर इज नॉट प्रेजेंट इन द पैटर्न वी कंप्लीटली मूव पास्ट अहेड दिस. एंड ये मूव पास्टिंग कैसे हुई? आई की करंट वैल्यू में क्या ऐड कर दिया? डायरेक्टली एम को ऐड कर दिया. सो दिस इंडेक्स डायरेक्टली स्विचेस पास्ट द पैटर्न. सो आई कीप दिस एज सेव्ड इन दिस इटसेल्फ. And you people can complete this further. So this is the worst case of Moore. Because we are comparing from right, ये mismatch जब भी आएगा तो एकदम last में आएगा after we have done so many comparisons. So again, this portion is read in this. Longer the pattern, faster we move on an average in Moore because we are pre-processing the pattern. और ये मैंने आंसर भी दिया कि we are shifting past ahead the pattern in itself. तो जितना बड़ा पैटर्न होगा उतना ज्यादा हम मूवमेंट्स आगे करते जाएंगे. So again you need to check, we just not check for alphabetic patterns in text. You might get binary strings as well. So this is a text that is these 5 characters repeated 20 times and the pattern is this. So again, जब right से matching start होगी from here, you get a mismatch and then you can continue. And here the matching is happening in the first character, so it goes on decrementing till the value of j becomes equal to 0. Okay. So again, this is a task for the GCR upload. So we take a break over here before we continue for KMP.
For the timing, can you write the Excel on normal sheets because the sheets are not available.
मुझे कोई constraint नहीं है, but वो तो I cannot comment on that thing.
So I wanted to ask that.
Okay, let us now begin with KMP, that is Knuth, Morris and Pratt, again on the name of the developers. So again, this is a link that is just a demonstrative link. उसको pause करके देख सकते हो that at each step how iterations are happening. So in brute force and Boyle-Moore, we were comparing mismatch character, right? And whenever there is a mismatch, we throw away the information and we were always restarting the comparison for another set of characters. In KMP, जो mismatch जहां पर होगा, that will be carrying some extra information that will bypass previously matched characters. मतलब कि कुछ characters अभी तक अगर match हो रहे थे in both of these algorithms, Boyle-Moore and brute force, I would have done these set of comparisons again. But in KMP, we are ensuring that कुछ set of characters अगर match हो गए थे पहले, I should not rework. I should not try to match them again. So that is how it reduces on the time taken to linear time. And there is a concept of prefix and suffix that is being used here. So if you people are able to relate, ये अगर एक pattern है in this entire text, there is a suffix that is also a prefix. दिख रहा है सबको? This AB is a prefix and this BA is a suffix of this pattern. अभी जब हम pre-process करेंगे pattern को, this concept will be used. That what is the length of the prefix that is matching with the suffix, or what is the longest length? So KMP algorithm compares a pattern. A difference from Moore is it is comparing from left to right, but it is shifting the pattern more intelligently, definitely with as compared to brute force. It bypasses re-examination of previously matched characters. For example, यहाँ पर AB has been matched, then there is a mismatch happening here. तो हमने क्या किया? इस pattern को text से align किया with the previously matched substring that is a prefix and a suffix. So AB को AB से align करने की कोशिश करी so that I need not compare A with A and B with B. So when a mismatch occurs, what is the most we can shift the pattern so as to avoid redundant comparisons? This is what I had mentioned just now. The largest prefix of the pattern that is also a suffix of the pattern. Because AB is the largest prefix, that is also a suffix. That is why we try to align AB with AB. ये तो हमने manually किया, but algorithm will take care of it by default automatically. So we need not do these comparisons which have already been done. We are directly beginning to compare from the position past these comparisons that have already happened. Okay, so what is being done by the algorithm is, again, this is what I had saved from another presentation during the Zoom meet. ये एक string दी हुई है, pre-process करके जो array मिलेगा वो ये मिलेगा. I am telling you people how this array is computed. So for this string, I am computing the substrings. So एक substring ये हो गई string की A. 2 length की substring will be AB, then 3 length की substring will be ABA, 4 length की substring will be this, 5 length substring is this, and this is the entire string. For each of these substrings, we are trying to find the prefix and the suffix. तो A का जैसे मैंने बोला था अगर single character है, that is why I had asked you people, उसका prefix and suffix is an empty string, so यहाँ पर कुछ भी common नहीं आ रहा. A, B में the suffix is B and the prefix is A, so again there is no match. अभी क्या बोला था last slide में? We are trying to find the largest prefix that is also a suffix. ठीक है? In this case, prefix is A and AB, suffix is A and BA. The largest prefix that is also a suffix is of length 1. So if you look here, ABA में I have written the length as 1. Here there was the length of the longest prefix that is also a suffix. The length was 0 if I consider the empty string is a matching string. And here also only the empty string was matching, so the length is 0. Again, let us move here. So here we have A, AB and ABA, A and BA. So the longest length is 1. तो इसी के लिए 1 लिख दिया. अभी यहाँ पर आते हैं. So we have A, AB, ABA, ABA, B, AB, AAB, BA, AB. So the longest prefix length is 2. AB. यहाँ पे 2 लिखा. Here you will find the longest prefix that is also suffix is ABA of length 3. So 3 has been written here. So this is how the pre-processing function for KMP works. This is totally different from how Moore was working. ये हमने पूरा process क्या किया? Manually किया. Now we'll see the algorithm for this and the logic behind it. There the function was called as in Moore. Pre-processing function का नाम was L से क्या था? Last occurrence function. Page पलट के मिल गया because you had written. Here the function is failure function, or we call this as a prefix table because हम prefix and suffix से compute करें. So the failure function shows how much of the beginning of the string matches to portion immediately preceding the failed comparison. as we manually see that यहाँ पे failed comparison है, preceding it how much is already being matched, that is AB has already been matched. That is why whenever we are looking in the failure function table, we will look for J minus 1th location. Okay, because of this statement, how much of the beginning of the string matches to portion immediately preceding the failed comparison. So here the comparison is failing. Immediately preceding the location is J minus 1. So in the failure function table, we are checking for the value in F of J minus 1th location. तो जब भी एक mismatch होगा, we will set we are changing the location in the pattern. तो J की value को हम set करेंगे as F of J minus 1. So my J value will not begin from 0, it will begin from F of J minus 1 failure function table से जो value return होगी. क्या हो रहा है यहाँ पर? J की कितनी value आ रही है और F of J minus 1 की इस table से क्या value आ रही है? Mismatch कहाँ पे हुआ? 5th location पे हुआ. So J value is 5. But we checked for in the failure function table capital F of 4, that is 2. So that is why this J location becomes 2. 0 और 1 को skip कर दिया. और ये हमें पता कहाँ से चला? Because हमने इस pattern को pre process किया हुआ था. We knew कि पूरी string में अगर substring इतनी है तो उसमें 2 length का prefix is matching the suffix. And from here only this 2 length has been skipped further and we can directly start comparing from here. So अभी हमने जो failure function table बनाई थी या array बनाया था, that was manually. This is the algorithm for that. So let us follow this algorithm. You people know the pattern. You people know the solution. We have to apply the algorithm. पूरा नहीं करेंगे तो भी चलेगा, but at least let us complete this till in mid. So for this ABA, this should be written with you people. We are following the algorithm. So सबसे पहले क्या होगा? F of 0 is 0 because remember वो single A का the prefixes will and suffixes will be epsilon. So F of 0 will be 0. I को 1 क्यों लिया? Because मुझे अभी 2 length लेना है. So this is my J and this is my I. That is why I'll begin from the right and begin from the left and start to compare. While I is less than M, every time I am incrementally increasing the size of the substring till it matches the entire string. वही किया था यहाँ पर. Incrementally increase किया था the length of the substring and last में वो equal हो गई थी to the length of the pattern. So we are going on increasing the value of I till it reaches M. We are comparing I with J in the same pattern. Index 0 और index 1 को compare किया. That gives me a notion that we have matched J plus 1 characters. If they are matching, तो automatically वो matching कितने characters match हो चुके हैं वो कहाँ से मिलता है? Failure function table से मिलता है. तो I change that table. So let us start doing this. तो मेरी I की value कहाँ पर है? 0 पे. I is at 1 and J is at 0, right? What is P of I? कौन सा character है? B. P of J is A. Are they matching? Not. So हम यहाँ पर आए. Is my J greater than 0? It is not. J is equal to 0, right? So again we are coming to else. F of 1 becomes 0. कैसे 0 हुआ? हमने मैनुअली जब किया था तो अगेन यहाँ से भी लेंथ 0 आई थी because A and B were not matching. So अभी तक we are same with manual process. So F of 1 becomes 0, I becomes equal to 2. तो हम क्या कर रहे हैं? अब हमने ये substring pick कर लिया. Right? I value is 2, J value is 0. So again we move here. Pi equal to Pj. Yes. AI equal to PJ. Those of you are not able to relate, ये मेरा I है, ये मेरा J है, both are same. So we have matched J plus 1 characters. कितने characters match हो गए? 1 character, जो कि हमने यहाँ पर देखा था जब ये सब string थी तो 1 character was matching. तो अभी मुझे value निकालनी पड़ेगी. So f of I becomes J plus 1, that is equal to 1. That is meaning 1 character has matched till now in the substring. I को increment किया, J को increment किया because the match was there. So now I am increasing the size. This becomes ABAA now. Right? No. So sorry. Now I am checking for the next characters कि 8 length का match तो है क्या, 2 length का match भी है. So I am incrementing these values in the if condition and then I am again checking for the values. So now what will happen is I am comparing P2 with P0. This is done. P0 and P2 is done. उसके बाद F2 की वैल्यू 1 आई, I3 हो गया और J1 हो गया. राइट, J0 था, I2 था, I3 हो गया, J1 हो गया. I is 3, J is 1. Compare these two characters. Is it a match? It is not a match.
Not.
So what I do is जब भी mismatch होते हैं मैं यहाँ पे else if J is greater than 0, yes or no? J value is 1.
Yes.
J is greater than 0. So I have to compute the new value of J from the failure function table because this is a mismatch. तो जब ये mismatch था तो क्या बोला था कि इसके previous character को look करेंगे in the failure function table. So f of 0 is 0. So my new value of J becomes 0. Okay, new value of J is 0. So now what do I need to check is I with J, I की value है 3, J की value है 0. अभी क्या हुआ, substring की length बढ़ गई and again I am checking from last and the first. So this is a match. So if this is a match, f of 3 की value क्या आ जाएगी? J plus 1 and J is what? 0. F of 3 we can see in the table is 1 as well. So likewise you people can compute the value for 2 and 3 as well. So ये हो गई how you are building the failure function table. Again it depends on the question if you have to solve it manually or you have to solve it through the algorithm. ये पूरी table build हो जाती है. The failure function code is very much similar to KMP match code. कितना टाइम लगेगा इसको प्रोसेस करने में? M टाइम लगेगा, एक ही पैटर्न है और उसी में हम आगे पीछे मूव करें. Again, why this statement is written? There are no more than 2m iterations of the while loop. 2m iterations कैसे होंगे in the worst case that you have to give a thought over. Now let me move to the KMP function. This is the entire thing I have solved over here. हमने कहाँ तक कर लिया है? 3 तक कर लिया है. f of 3 की वैल्यू 1. ठीक है. Similar thing. No, Zoom की recording से you will get for Boyer-Moore. Otherwise, similarly, I'll try to prepare the slide as a solution for Boyer-Moore का failure function in the main algorithm. Now let us move ahead. KMP का, can you see similarity between this and failure function वाला code? वहाँ पर भी I जो 0 initialize था. This is an extra line written here. वहाँ पर we were iterating till the value of J was less than M. This is still N. We were comparing. And comparison के बाद we were checking, we were trying to initialize the value of fi. Here what we are doing is we are trying to find कि match कहाँ पे हो रहा है. So now let us apply this on the string you have to write, right? String is ABACA. I think it is after this. Yes, please note down the string. And again, I have tried to put in the values of the algorithm here at each step. ऐसा तुम लोगों को आंसर करना है फॉर एनी ऑफ द क्वेश्चन आस्क्ड, whether it is brute force, whether it is Moore, or whether it is KMP. So you have to just copy the string. You can copy it till half as well, so that we begin execution of the code. A B A C double A B A C C. Till there it is fine. We can check for 2 iterations. And we were checking the failure function for a different pattern. This is a different pattern, please note. So this pattern ke liye again the failure function table has been given to you as 0 0 1 0 1 2. ठीक है, so let us start the algorithm. अभी एल्गोरिथम क्या कर रहे हैं, हम KMP में लेफ्ट राइट मूव कर रहे हैं. इसके लिए I is initialized as 0 and J is initialized as 0, and we have already pre-processed the pattern. That is why I have my F value with me, capital F value. And we have to repeat these iterations till we reach the end of the text. So what do I need to do is I need to compare ith character from text to jth character from pattern. यहाँ तक it is simple. ऐसा इंक्रीमेंट करते करते एंड आगे मूव करते करते if I have reached to the end of the pattern, I return what? Why do I return I minus j? I am beginning from the left, moving towards the right in text and in pattern. I go on matching. The entire pattern matches the text. Why am I returning I minus j for the match? First occurrence of the string. एक ही string है तो एक pattern एक ही बार है text में तो. This is very logical and very simple. My question is, why am I returning I minus jth index? कहाँ पे मैच हो रहा है इस एल्गोरिथम को करके? Is the match happening at 0th index or the match is happening at first index? So should I return 0 as the value or should I return 1 minus? हाँ, लेकिन जब भी मैं मैच कराती गई, so these set of iterations will stop at this location. So this is my value of I. So if I return I, the match location will be this, and I have to return this. So we are subtracting the iterations, the indices which have that is equal to the length of the pattern. Okay, so that was a simple one. कितना हो गया अगर मैच करते करते हम आगे बढ़े and the entire pattern has matched to the text. Then when are we moving to this part? Else part, any one of you?
If the pattern is not completely checked.
If the pattern, रुद्रांश complete तो किया करो.
Ma'am, if the pattern is not completely checked.
If we have still more comparisons left, तो that is a simple case. अभी भी if है and हम pattern के end तक नहीं पहुंचे, तो I भी increment होगा, J भी increment होगा. कहीं पर भी mismatch आता है, then what? Then again two conditions जैसे पहले भी थी कि are there more elements available in the pattern? If there are, then I need to check कि pattern में कहाँ पर positioning करनी है. The intelligent index that my failure function table is returning. So that I will get from here. और j minus 1 क्यों करेंगे? Again the same reasoning. जहाँ पर mismatch होता है, I check for the previous comparisons because I have to check how many comparisons I can skip which have already happened earlier. Then if j value is not greater than 0, that means j is equal to 0. That means my pattern के beginning पे हूँ, so I will increment only I and I have to compare from the beginning of the pattern, that is the first character only. And if while doing this I reach to the end of the text, I return -1. So let us do for those two iterations which I mentioned. जा रहे थे तुम? Yeah. So let us begin. You people have mentioned the text A, B, A, C, A, B तक बोला था मैंने, I think. Till here I told A, B, A, C, A, B, A, C, C. So let us check for the first one. So A, B, A, C, A, B. So my I value comes from 0, 1, 2, 3, 4, 5 and J is till 5. यहाँ पे mismatch हुआ. I and J are 5. I move to else. J is greater than 0. Yes or no? So what will be the new value of JB? F of what? F of 4. F of 5 minus 1, that is F of 4. और F of 4 की क्या value लिखी हुई तुम लोगों ने? 1. So my new value of J becomes 1 and as you can see here, ये यहाँ से alignment होगा. We have skipped this matching because this matching had already happened earlier. So I'm not doing work again of comparison which have already been done. So now let us check for here. I value ये रही, J value ये है. So I'm comparing A with B again. I is 5 and J is 1. There is a mismatch. I go back. So J will be F of, that is F of 0. So F of 0 की value 0, J की value 0 हो गई. That means now you can see ये 0 हो गया. Right? So again starting the matching here, 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 here and here there is a mismatch. So in this case what I am comparing is I is 9 and J is 4. तो 9 और 4 का मिसमैच हुआ लेकिन अगेन J की वैल्यू इज ग्रेटर देन 0. सो J की नई वैल्यू क्या हो जाएगी? F of 4 minus 1, that is 3. So F of 3 कितना है हमारा?
0.
So again if you see here, J वापस 0 पे आ गया. So likewise you have to show these iterations in these steps until you reach to the end of. Until you reach to the end of. ये कितना iterations होंगे? नहीं. What I am asking is if you're given this text in this pattern, do you need to show more steps till we reach end of this? So due to which line are we stopping there? Due to which line in this code हमने iterations वहीं पे stop कर दिए जब match मिल गया? Anyone online?
Return I minus J.
रिटर्न तो तब होता है जब कोई कंडीशन चेक होती है. किस कंडीशन की वजह से रिटर्न हो रहा है? So my J value which I go on increasing till the J value becomes equal to M minus 1 here. So you have to show here जैसे J की वैल्यू मैंने सब जगह लिखी हुई है वैसे जहां पे भी एक J की वैल्यू आएगी. Why? Because we are incrementing J from 0, 1, 2, 3, 4, 5. J has reached equal to M minus 1. So again, this question is for practice and the task that first you have to apply the failure function का algorithm, then you have to apply previous slide में जो algorithm है onto this particular example. Either you can do this one, either you can do जो अभी discuss किया, any one example you can do as part of this. So you can see that यहाँ पर the time complexity is linear. Failure function compute करने में खाली pattern को process करना है और string को search करने के लिए खाली text को process करना है. Thank you all. So that was all for today. Anything from your side, online students?